Hello my dear learners, I am Dr. Pawan Kumar Shukla and I am professor at RKGIT Ghaziabad in the Department of Electronics and Communication Engineering. As I am taking the lectures of antenna and wave propagation, and in my few of the last lecture I was discussing the radio wave propagation topic, and basically radio wave propagation topic, it is a very wide and very vast topic, and some of the characteristics of ionospheric propagation I was discussing in the last lecture. So, I am continuing the same thing, and some of the parameters today I will discuss regarding the ionospheric propagation or skyway propagation. As you all know that skyway propagation is the propagation which is limited by a frequency of 2 megahertz to 30 megahertz, and this is the only mode of propagation which can cover the longest distance on the earth, and the reason behind this longest distance communication is the reflection from the ionospheric region of the atmosphere, the radio waves which are being propagated in the atmosphere and they are reaching to the ionospheric layer, and after the multiple refractions the radio waves are reflected back to the earth, and this mode of propagation is known as the sky wave propagation. So, we will discuss some of the important parameters related to sky wave propagation in terms of critical frequency, virtual height and some of the other parameters. So, first of all we will discuss how this reflection or the complete reflection of the radio waves from the ionospheric layer, how it is possible. So, let us start the propagation through ionosphere. How this propagation or how this refraction or reflection takes place in the ionospheric region of the atmosphere. As we all know that ionosphere is the layer of the atmosphere which ranges from 50 kilometer to 400 kilometer above the earth's surface, and when any radio wave is reaching to that height of the atmosphere, as the lowest layer of the ionosphere is D layer and it is situated at the 50 kilometer. So, when any radio signal is reaching to that height, either it is penetrating the ionospheric region or it is reflected through the different ionospheric layers like D, E, F1 and F2, which are situated at the different heights in the ionospheric region. So, let us assume that the ionosphere is lossless and it is having a relative permeability of unity and can be modeled as plain stratified media as shown in the given figure. As might be expected that when a radio signal is entering into the ionospheric region, obviously the different laws of optics are considerable and applicable in this radio wave propagation theory, because light is also a wave, and that is why the Snell's law can be used to understand the theory of sky wave propagation, or we can say the reflection of the radio waves through different ionospheric layers. And this diagram shows the multiple refractions through the ionospheric region. As we see that this is the lowest layer of the ionosphere, and at this particular layer when the refraction takes place, as we all know that the ionospheric region is having the refractive index less than 1, because it is a rarer medium than the medium on the earth. So, when a radio signal is entering into the medium which is rarer than the atmosphere, then the medium which is having the refractive index as unity, we can assume that below the ionospheric region the atmosphere of the earth is having a refractive index which is equal to unity, and when it enters into the ionospheric region, this is the medium which is having the refractive index less than unity. So, the radio signal is entering from denser medium to rarer medium, and when it is entering into rarer medium, then this is the angle I and this is the angle R1, and after that definitely the angle R1 is greater than angle I. So, obviously, when it is reaching to the multiple layers of the ionosphere, the angle of refraction is increasing continuously, and at one particular point when the angle of refraction becomes 90°, and this is that condition. At this particular condition, when the angle of refraction becomes 90°, the situation comes and it is given as the completely internal reflection, and after that the radio wave or radio signal is bending, and when it is bending towards the earth, it can also be said that the signal is reflecting back to the earth. This is the complete phenomena of the propagation through ionosphere. So, simply the wave path can be predicted by using the Snell's law. Obviously, if we talk about one particular medium, when this is, then this is I, this is R, this is the angle of incidence, this is the angle of refraction. So, definitely the angle R is always greater than angle I, and when this, according to the Snell's law, we can say that sin I upon sin R, it is always less than 1. That is why it is said that this is the simply refractive index of the ionospheric medium is defined by this particular parameter as sin I upon sin R, which is less than unity. And when this is less than unity, the ionospheric medium is having the refractive index less than 1. So, simply all the formulas, all the derivations and all the theories in the ionospheric region is based on the concept which is saying that ionospheric region is having the refractive index less than unity. So, the multiple refractions are going through in the ionospheric region, and the result is like that the relative dielectric constant is a function of the electron density n. As the electromagnetic waves propagates wave deeper into the ionosphere, and it passes through a region of higher n into the region, and the finally by different category of formulations and mathematical expressions, equations, we finally can say, because in my last lecture I was discussing the complete derivation of the refractive index of the ionospheric region, and it is given as refractive index of the ionosphere is equal to the under root 1 minus 81 n max upon f square. This is a very important formulation of the refractive index of the ionospheric region, and different theories, different concepts, different parameters of skyway propagation. For those particular parameters, this will be the deciding factor. So, we will study many more concepts related to this particular formula. which says that the refractive index of the ionosphere is equal to under root 1 minus 81 n upon f square. What is the critical frequency? The critical frequency for the ionized layer of the ionosphere is defined as the highest frequency that can be reflected back to the earth by a particular layer for a vertical incidence. Here this particular word is very important, which says that at vertical incidence. Vertical incidence is having the property like this: when any radio signal is reaching to the ionospheric layer in this manner, this particular condition is known as the vertical incidence. Vertical incidence means I is equal to 0, and when this I is equal to 0, it means this is like this. When this is, then it is the, this is the angle. So, sin I is equal to 0, sin 0 means 0, and when it is 0, then under root 1 minus 81 n upon f square is also equal to 0, and when under root 1 minus 81 n upon f square is equal to sin I upon sin r, that is equal to 0. Because I is equal to 0, then we can assume as f is equal to 9 under root n, and at that particular point this electron density must be maximum at that particular height, and it is known as n max. So, this is known as the critical frequency and it is denoted as f critical. This is the formula for the critical frequency, and it is given here that FCR is equal to under root 81 n max, means FCR is equal to 9 under root n max. Okay. So, as the frequency of electromagnetic wave increases, the virtual height also increases. What is virtual height? We will discuss later, and slightly indicating that the wave of higher frequencies are returned from higher levels within the layer. As the frequency approaches to the critical frequency like 5 megahertz for the F1 layer, the virtual height steeply increases. This is the case of virtual height and the critical frequency. Once the critical frequency is crossed, it means any operating frequency of a radio signal which is propagating into the ionospheric region is having the frequency higher than its critical frequency, then what will happen? Obviously, critical frequency is not the highest frequency which can be reflected back to the earth after the refraction from the ionospheric region, but it is the maximum frequency only at the vertical incidence. It means when I is having any of the value, the range of that frequency, the limit of that frequency or that maximum frequency which is known as critical frequency can be exceeded, and when it is exceeded, it means the critical frequency can be maximized up to a more level. So, simply we can see that consider an electromagnetic wave which is launched vertically into the ionosphere having a maximum electron density n max, and substituting theta I is equal to 0, we can get the highest frequency which is known as the critical frequency and is given as like this. Next, what is virtual height? Basically, virtual height is the height which is hypothetical or which is virtual, but the concept of virtual height is very real, because all the assumptions, calculations, analysis is made by using the concept of virtual height itself. When a wave is refracted, it is bent down gradually, but not sharply, because it will be bending sharply only when the reflection takes place, not refraction. But when refraction takes place, it means the path of the wave, path of the refraction, multiple refraction is always gradual path. So, the difference in both kinds of path after the refraction or after the reflection, it is providing the concept of, it generates the concept of virtual height. Suppose an electromagnetic wave from a transmitter reaching to the receiver after being reflected by the ionosphere as shown in the figure means multiple. When this process occurs, this process occurs only by the multiple refractions when it is having different layers in the ionosphere and each layer is refracting the radio signal which is being propagated into the ionospheric region, and every layer, after the refraction from every layer, it is bending gradually, and the path of the real path of the wave, the radio signal is like this. This is the real path. But when we observe from the earth's surface, we can assume only that there is a very sharp layer at this particular point O, and the signal is reaching to the height at O and it is just reflected back to the earth. So, this is the path which is the resultant of the reflection, but this is the path which is the resultant of the refraction. That is why it is gradual path and it is straight path. So, the height corresponding to the straight path is known as the virtual height, and the height corresponding to the gradual path is known as the actual height, and this is the difference between the virtual and actual. So, this is the actual height, here the process of refraction takes place, and this is the virtual height. It means that at that particular height reflection process takes place. So, we can understand this theory by using the different concepts like, let the wave enter into the ionosphere L, as I have shown in the last figure, that the curved path L M N, before it emerges out of the ionosphere, the height at a point above the surface at which the wave bends down to the earth is called actual height or true height, and this height is corresponding to the process of refraction, not the process of reflection. The virtual height from the ground to the point O is known as the virtual height from the ionized layer, and it is not the true height, and this particular formula as H is equal to C into T by 2, where C is the speed of light and T is the time period, the complete time period which a radio signal takes from when it is going towards upward and reaching to the ground surface. This complete time period is known as T. So, half time of this complete time period is considered to get the virtual height, and that is why we can calculate the virtual height by using this formula. So, simply we can say that this particular diagram is complete itself, in which we can formalize, or we can say that we can define the concept of virtual height in the skyway propagation or ionospheric propagation. So, simply ionospheric layers are situated at a very wide range in the atmosphere, which is from 50 kilometer to 400 kilometer, and a radio signal can be reflected back to the earth after the reflection either from D layer or E layer or F1 layer or F2 layer. So, different kinds of layers are providing the different characteristics to the radio signal when it is reflecting back to the earth, and simply we formulate all these parameters on the basis of the characteristics of the ionosphere, because it is definitely nature based phenomena, and skyway propagation is a very special type of phenomena of radio wave propagation. So, simply in skyway propagation there are very important parameters which define the accuracy and the performance of ionospheric propagation, because as we know that the semi circumference distance on the earth surface can be covered through the skyway propagation only. This is the only mode of propagation which can achieve the longest distance on the earth, and this cannot be happened only in a single hop propagation. Multi-hop propagations are also possible in skyway propagation. In one particular hop only 2000 kilometer or 4000 kilometer on the earth's surface distance can be covered, but in multi-hop propagations when multiples of the hops are covered, then 20,000 kilometer distance can also be occupied between a transmitting end or between a transmitting and receiving end, and this is the distance, this is the longest distance on the earth, this is the semi circumference of the earth, where at one end transmitting antenna is standing and at the other end the receiving antenna is standing, and the distance between a transmitting and receiving antenna is the distance equivalent to the semi circumference distance of the earth. So, simply we can say that skyway propagation is the propagation which can cover the longest distance on the earth's surface, and these parameters are responsible to analyze and to study about the different phenomena, different characteristics in the skyway propagation. So, thank you very much for watching this video. In my next lecture, I will discuss some more important parameters related to the ionospheric mode of propagation. Thank you very much.